Hi students, and welcome to the end of chapter 4 lecture. We're going to be talking about types of biodiversity and species, mostly types of species, and there's a lot of different ways to categorize species. So when I first put together this lecture, I Googled strange looking species, and you can see a bunch of examples on this first slide here. And this one kind of like freaks me out a little bit, the bald acori, but look at some of the bugs. The giraffe weevil is also really strange looking. Here's some more strange looking ones. The one that might give me nightmares is this deep sea squid with the teeth, like, ah. Anyway, I never heard of any of these things before I gave this lecture, but they're really strange looking. So let's get into these different types of species. So first of all, when you're looking at species, you're looking at diversity. So there's a few different ways to categorize diversity from the small moving up to the large. First, there's genetic diversity. So within a population, what kind of genetic diversity, the range of genetic material you have in that population. Then moving up, there's species diversity. How many species do you have in an ecosystem? And going up from that, how many different habitats or how many different ecosystems do you have? So, how many different habitats per unit area within an ecosystem? So in general, the more habitats you have, the more biodiversity you're going to have. When you think of Washington State, we have a great range from west to east from different types of habitats and climates, et cetera, and it leads to quite a lot of biodiversity in our state. So within there's two components of species diversity. And one is just exactly if I asked you like how diverse is the area, the first thing you would probably do would be to count how many species are in that area. And say you find 20 species that you would say, hey, that's pretty diverse. But there's a second component to that that is just as important. So that's the first one's called species richness. The second component is called species evenness. And what that means is that's the relative abundance of each of those different species. So say you have those 20 species in an area, if 95% of all the living things you find in that area are one species and the other 19 species are not that prevalent, you're going to be less diverse than if you had like equal distributions of each of those types of species. There's another term called population bottlenecking, which means that there's some kind of disturbance that drastically reduces your population size. And when you drastically reduce a population size, you're also going to be reducing the genetic diversity. There's going to be fewer individuals surviving to carry on to the next stage or for the recovery. So two things can happen. One is that you might reduce it so far, they're going to be more extinction prone because you don't have enough individuals left, or they can recover. But that recovery can mean that you're now recovering with a different set of genes or a reduced set of genes than you had before. There's something else called genetic drift, which is when you get a shift in the gene pool, not because of natural selection, which we talked about in the last lecture, but more due to some kind of random loss of that genetic variation. And that can be from a bottlenecking event. So there's various kind of examples here on this slide, which you can pause the lecture if you'd like to and look at them. This one here is pretty easy to see that you had a lot of diversity originally, and then there's a bottlenecking event, and what was surviving from that had less diversity than the original population. And so carrying forth into the future, you have less diversity. So, this is bottles and marbles and bottles and that kind of thing. How does this play out in the real world? Well, the American bison are actually a great example of a bottlenecking issue. They used to number in the tens of millions. They used to just cover the heartland all the way into the western up to the Rocky Mountains. And they were hunted to near extinction when white people basically colonized the United States of America. And there were fewer than 1,000 surviving, down from the tens of millions. So you can imagine their genetic diversity was greatly reduced. So now you can go see buffalo in places like Yellowstone Park or Custer State Park, but their populations are now very isolated from one another. They don't mix. And if it's a small population, say in Custer State Park, there's not that many of them, you're going to have much less genetic diversity than when they used to range over the entire western half of the United States. Other things we should talk about, these are kind of review from biology, but the habitat, which is the location that a species is found in, and the niche, which is the role of the species in the ecosystem. And that's going to be related to that. That's going to include all of these things you see in the list, like all the conditions, abiotic and biotic, the resources, the interactions with other species and components of the ecosystem, and the role that that organism plays in the flow of energy and the cycling of matter. So think of the habitat as the address and the niche as the occupation of the organism. We're going to see a video on this in class, but just realize when you look around planet Earth, tropical rainforests have the greatest biodiversity of anywhere on the planet. And in this little video we'll see in class, we'll explain why. More ways to classify species. There are two kind of broad categories we can look at as generalists and specialists. And they're just exactly what you would think. Generalists have broad niches. They can like survive. They're very adaptable. They can survive in a broad range of environments. And specialists, which have a very narrow range at which they exist. And so species of generalists, cockroaches, coyotes, raccoons, humans, we can pretty much adapt to live just about anywhere. Specialists, the spotted owls, which will only live in old growth forests, the American condor, which is very fussy, the panda, which has to live in bamboo forests. So what are the pros and cons of these guys? And these just show that these niches will overlap with each other. What are the pros and cons? Specialists, if conditions are stable, they can often outcompete the generalists because they're very good at what they do. They've evolved to live in that habitat and thrive. Generalists, however, thrive when conditions are changing. So because they can adapt and they can live just about anywhere, they thrive then. So you can imagine that right now our world is changing pretty rapidly due to climate change and human expansion across the planet, that our generalists are often doing better. So like the raccoon has evolved to like coexist with humans really well. So more categories of species. There's, again, you can divide things up in these two categories as native species, species that have evolved to be in an area, and non-native species. And unfortunately, the non-native species one has lots of different terms for the same thing. And so you can call them exotic species, alien species, and usually I'll call them invasive species. They originate in other ecosystems. And I don't know if this is the reason there's so many names for them, but they're very important when you talk about biodiversity, because next to like habitat loss, they are the #2 reason why species go extinct, why species get in trouble. And you wouldn't necessarily think that at the outset, but invasive species can cause a lot of damage to an ecosystem because you're introducing something that was not evolved to be there. So just when you look around our area, it's kind of amazing, but a lot of what you see is not native to this area. So if you've ever seen that gunk in Lake Washington, that's a water milfoil from Eurasia, English ivy from Eurasia, the butterfly bush, freshwater animals. I'm not going to go through this whole list, but even the eastern gray squirrel, I was like, really, the squirrel? Like, that's not endemic to here. And birds like the house sparrow. So all of these things were introduced, and just in time for 2020, we have yet another new invasive species to the area, and that's the murder hornets. So I'm sure you've heard of them. They're actually called the Asian giant hornet, but they're huge. I mean, look at these pictures. And they're not called murder hornets because they do people a lot of harm, although I guess their sting is way worse than of a normal wasp. But they decapitate bees. They can literally take out a honeybee hive in a few hours, which our bees are already in trouble. So this is a species that could potentially do a lot of damage if it really takes off here. They've been doing their best to basically put little trackers on these guys when they can catch them to try to wipe them out before they start spreading and creating new nests and take over in this area. But I just saw a report on the news tonight, and it's not looking good. Their little trackers so far have not been able to stay to the point where they can find the main nest. And they're hoping it's still one nest. But if we miss this window right now when they're active and feeding, there might be several nests by next year. And then once these invasive species take off, it's really hard to eradicate them. So as far as like, when they'd hit the Seattle area, if they do start to take off, they can fly up to 68 miles per year, or that's kind of their spreading rate. So they could be all the way down into Oregon within 20 years, calculate from the Canadian border down here how many miles that is, and they could be here within a few years. So yay, murder hornets. Okay, so, what can you do? So I already said, prevention, like try to keep them from taking off. Once that happens, the best you can do is containment. You can try to remove them, but generally when you try to remove a species and the methods you use can often harm the species that you're trying to protect too. So, invasive species are really hard once they've basically taken root in an area. more species types. Endemic species are species that only occur in that one area. And generally you tend to think of endemic species like at small island nations, places that are geographically isolated, rather than like huge areas, like where you might say like, oh, the Western squirrel is endemic to Western North America. Generally, this is usually used for smaller areas, but you could probably apply it to more things too. So some examples: the Australian ghost bat, the Madagascar lemur, the Galapagos land iguana, and then other species types. Indicator species, again, most of these are pretty self-explanatory. They serve as early warning signs, the canary and the coal mine species, which is a phrase I get tired of in environmental science. But these are species that are highly sensitive to their environment. And often if you see their population start to decline, it's a sign that the ecosystem's in trouble. So the decline of migratory songbirds, sign of habitat loss. Presence of trout in mountain water means that it's a good clean water. The spotted owls means you have that old growth forest, etc. And then frogs are highly sensitive to pollutants. So when you see frogs in trouble, it's a sign that there's some pollutant out there in the ecosystem. So we're actually seeing a lot of frog species having a lot of trouble right now, and there's a lot of reasons for it. I'll let you kind of read through this slide. But frogs are a pretty big indicator. Lots of different species are indicator species, and we're actually losing frog species pretty rapidly right now. So other types of species, the keystone species is a species that's super important, plays a critical role in an ecosystem, and there's kind of a few categories within this one. So top predators are often keystone species, and again, we'll see a video in class about the wolves in Yellowstone. Examples: sea otters. They keep sea urchins from like depleting the kelp beds, and the kelp beds are an important habitat for a lot of marine species. Dung beetles remove animal waste. Wolves in Yellowstone, we'll see the video. And there's a little quote from E.O. Wilson. And this is a picture of a bunch of keystone species. And then you can look up the various reasons why they're all keystone species. We won't go into it all here. But there's also something called a trophic cascade. And this is when you have the effect of an increase or decrease of one species and the effect it can have on the other trophic levels. So again, the wolves in Yellowstone are a great example, and we'll see that little video. But also sharks, the top predators, what they do is they keep control of the next step down on the food chain. And say the wolves in Yellowstone, they keep the deer population down. Without the wolves, the deer overeat their habitat, and then you have lots of destruction that can happen. In the water, sharks can play a similar role. So again, sharks are another keystone species, and we'll see this video in class too. Foundation species are kind of like, they're like a type of keystone species is the way I look at it, but they literally, their role is slightly different. They actually create or enhance their habitat. So you might have seen the otter and the keystone species like montage of pictures earlier, but beavers, if I said otter, I meant beaver, they build dams and they actually create the habitat. They'll create lakes by the building of their dams. And then elephants, actually, they stomp down these grassy areas, and it actually leaves it open for grazing species. So they're considered foundation species because they kind of help create the habitats that they live in. So we're not going to discuss this with your table partners, but sea stars are another one, and they eat mussels and urchins in the tide pools. And if you can see the little graph at the bottom, it looks like it's a little cut off. But if you take the sea star out, the Pisasters, that's I guess official name, your number of species present declines. And what was really kind of serious was they're recovering now, but a few years ago there was a sea star wasting syndrome. And I live in West Seattle. I used to go to the tide pools. You'd see sea stars everywhere, and then they basically disappeared. The last time I went, last summer, they're starting to come back again. So it's nice that it looks like they're recovering. But if you lose that species, they're an important keystone species for the tide pools. So again, and they're a keystone predator. So again, predators can kind of keep control of other things that might overeat their resources. And that's the end of our lecture. So we'll see you back for the next lecture, which is going to be chapter 5.